Hello and welcome to Maker's Muse. In this tutorial in Fusion 360, I'm going to show you how I designed this solid of constant width, a Reuleaux Tetrahedron, and I made it easily 3D printable using the patch workspace in Fusion and the modeling workspace. So let's get right into it. Okay, so the basis of our Reuleaux tetrahedron is actually a regular tetrahedron, and in the previous video I showed you how to draw that properly, in my opinion anyway. I'm not using a extrude with a taper angle because that uses rounding. I'm actually going to draw it again like I showed using a loft, but you don't actually strictly need it to create the Reuleaux tetrahedron because we're going to be using spheres that intersect with each other. It's more of a scaffold. So basically, as I showed in that previous video, I've got a sketch here and another sketch here. And those edge lengths are exactly the same. And that's what I'm using to create my regular tetrahedron scaffold. And just to show you again what the loft looks like, here is a lofted tetrahedron. So edit feature, it's the profile here and the point here. And that goes up to a point and leaves us with perfect regular edges. But as I said, to actually draw the Reuleaux tetrahedron, we're actually going to use spheres. So we're using it as a scaffold. So I'm just going to hide that for now, because you actually don't need it for the actual drawing of this. What we do need is spheres. You actually need 4 spheres, and they interact with each other to create our shape. So to draw that, I'll show you how this sketch works. Top plane. Okay. So this is a sphere drawn at one of the corners of our triangle. And like I've shown in my previous solids of constant width tutorials, it has to pass through the corners of the other 2 corners of the triangle. And it has to be, in this case, it has to be an equilateral triangle, and it's going to be quite a large sphere, and you need to have an axis that you can rotate this sphere around to create a solid, so that's why this axis is here. It could be anywhere bisecting the center point, but that's fine to me. And you only need to draw 1 because we're going to actually pattern the resulting sphere to create our final, or at least 3 of them, of our Reuleaux tetrahedron. So move this forwards to revolve and edit feature. You can see the revolve is that sphere, and it's a new body. Important, all of these will be new bodies. They're not going to be joined in any way yet. And then I did a pattern. So this is where I saved myself some time. So the triangle needs 4 spheres, but because I drew the original triangle on the top-down plane, which is the XY plane, and the axis is in the center, I can actually do a rotational pattern, which is what I did here, and that axis that I chose is the center axis right there. So you can actually see it under origin. You can see our various axes here, and it's actually the Z axis. There you go. And then, of course, it's 3. It has to be 3, and type is full. So 3 equally spaced will perfectly line up on our sketch. And then you need to do 1 more sphere, and this one will be on the same plane that we used to draw the second part of our regular tetrahedron scaffold. So it's going to be on that plane. I'm just going to hide the other bodies temporarily so it helps you visualize. So I'm going to go to edit that sketch, edit here. Same plane, and the center point has to be on that point there. And once again, you need to make sure it passes to the correct point. So the center point is here, and it's going to be coincident to this point here, which is the bottom part of our tetrahedron. Right click, coincident. And that's actually all you need to lock it in place. You don't need another point of coincidence. That's perfectly fine for this. And that looks good to me. And of course, the axis I've just put there to make our sphere. And make sure you can see it. And then another revolve. Once again, the revolve is a new body. Okay. And that leaves us with 4 spheres, which we will use to create the intersection of those spheres to create our Reuleaux tetrahedron. This is the fun part. So to do that in Fusion, we're going to combine them using the intersect command. So edit feature to show you. So I do these 2 at a time, so you choose just one of them and then another, it doesn't matter which ones. So for example, target body here, tool body there, doesn't matter, you just do 2 at a time, and you can see it causes this like flying saucer-like shape, which is a good start. It has to be intersect, okay. And then step forward again, you do another shape referencing back to referencing back to the one we just modified. So for example, again, target body here and tool body here. It doesn't actually matter which one. And okay. And finally finishing up with the last sphere, which is here. Edit feature. Doesn't matter again. There we go. And that leaves us with the intersection between all objects. Some CAD programs might be able to let you do that, all of that in one go, but Fusion prefers it one at a time, whatever, it's fine. And this is the intersection of all of those spheres, which leaves us with a Reuleaux tetrahedron. But that's not very easy to 3D print, so this is what I ended up with, and it's actually made up of 4 different quadrants, 4 different sections. And each of these is easy to 3D print, and then I have a center joiner, which they all join into each other. So let me show you how I did this. And this is just how I design parts to be easy to 3D print and slice them up. You might have your own preferences, that's fine. But basically to start, I hollowed out this shape. So I did a shell. And the shell is in 10 millimeters. So if you have trouble visualizing shells where you don't actually have an open face, I'm not selecting any face to be open, then you can go and do a cross section. So inspect section analysis. This helps me visualize it. So cross section there, 10 millimeters in, that looks fine. And then I went over to the patch workspace, which lets you draw 0 thickness surfaces. And that's how I actually sliced it up. I didn't slice the solid, I used the solid as a framework to make surfaces in the shape I wanted. So to do that, I went over to the patch workspace, model patch, and this is known as an offset. So what it is, if I right click, edit feature, this selects existing faces, and then you can choose to offset them. So normally you would offset them like 3 millimeters, for example, but I'm doing 0, which means they're just a copy, basically. I'm copying the existing solid into a 0 thickness surface, and they are new bodies. Okay. So if I hide my existing body and just turn the cross section off, that's what we're left with. We're left with these 2 0 thickness surfaces, which I can now use to inform my sections of the model. But obviously 0 thickness isn't 3D printable, so I need to join these into a solid. And to do that, I'm going to do a loft, but this is a surface loft or a patch loft. And to show you how this works, edit feature, I select one of the profiles and then one of the others, and it will join between the gaps. So to demonstrate that from scratch, I'm going to select the outside profile of one of the 0 thickness surfaces, and then I'm going to select the outside profile of the other. And once you complete it, it automatically goes between the two. And like our loft for the regular tetrahedron, as long as you don't change any of the guide types or connecting types, it will be a perfect straight line, which means these objects will not affect each other when they're being printed, which is really handy. So that angle we have here will be perfect. But this is still a 0 thickness surface. If we go to analysis, you see it's not a solid yet. So we need to make it a solid, and you do that using the stitch command. So under the modify, we have stitch, or it's in my shortcuts here. So what stitch does is takes the 0 thickness surfaces and stitches them into a solid. Very easy to do on an object like this. Other ones might be more complicated, but I just select all the faces, or the surfaces rather, and then it has a tolerance that's going to be unnecessary here because everything's right against each other. And then, okay. And you see over here that our surfaces are gone, our patches are gone, and now we just have a solid. So under the cross-sectional analysis, we now have a nice solid. Excellent. Okay, so now we have our pieces. Now I need a way for them to join to each other and to be easily 3D printable. And the first thing I thought was this inside curve, like the Rubik's Cube parts I've been printing, that you want that to be flat. So I'm going to print them like this with a very low layer height so I still get reasonable surface finish. So the first thing is to get rid of this. So there's various ways I could do this in Fusion, but the way I prefer is to use a plane and then cut down into the object to give me a nice flat surface to work with. And to do that, I created a plane using 3 points. So I'm just going to go back to the model workspace. So under construct, you want a construction plane that goes through 3 points like this. And to show you how that plane works, I just literally select the 3 points of my object. And it gives me a construction plane that is perfectly in the right location for doing an extrude cut to cut down into the object to make that area flat. So I put a sketch on that construction plane. And it looks a bit nuts. Don't worry too much about that. It's just showing previous sketches. I did a project here to get the center point. So I projected the original geometry, which is there, to get a center point. And to work with that, I just did a circle to just cut through. I mean, it's very arbitrary. I just needed to make sure I cut through enough of the object. Hide the plane again. And then this extrude cut, as you can see, edit feature. The extrude cut goes down 2 millimeters, like that. There you go. And I selected OK. So that's good, but I still have this remnants of the curve there. And this is where in Fusion, it's actually really easy. You can actually just literally hit delete. So you can just delete that and it will just fill in the gaps. Possibly not the best process or method for doing it, but that's how I do it anyway. So what this has left us with is a nice flat surface for our edge for the Reuleaux tetrahedron. Next was to add some sort of joiner. So to do that, I drew a sketch here, which again is using projected geometry and the center point. And this is a cylinder. This is going to be a bore. I set it at 10 millimeters. And the idea is the bore will join onto a little mini sort of peg that goes into the part and lets me snap them all together. And then I did a extrude cut down into the object. But before moving on then, I wanted to give the object a little bit of a sort of bevel around the edges, just a little bit to remove any sharp edges because they generally interfere with things fitting together, which is just simply a chamfer going around the object. I just selected those edges there. I didn't want to select the bottom ones because it's printing flat down and it's not going to interfere. It's fine. You could if you want to, but that was fine for me. Okay, now this is where I ran into a little bit of an issue. So you generally want to try to think way ahead in terms of 3D modeling like this in Fusion 360 parametrically. And I want clearance between my parts because, 3D printing isn't going to be perfect. And we've got a 0 thickness between the parts currently, whereas if we print them, we need some clearance. However, to create my center peg, I need to do a mirror, and I'm going to need to use these faces here to do it, which I'm going to move by doing an offset for clearance. So I'm going to just preserve them by using another patch. This is using patches as construction geometry. It's totally cool. It's fine. It's a really good way of making sure things don't move when you might modify the shape. So this is the shape without any clearances yet. And I'm just going to drop in, so create offset. I'm just going to drop in some copies of this, and this face. So 0 distance, okay. And you can see those here. If I hide the body, which I can use as my mirror planes. So I'm just going to hide them away for now because I don't need them yet. But I'm going to now do my clearance, which is a simple push-pull command. So going back to the model workspace, it's using the press-pull. And as you can see here, edit feature, I just selected those faces, which I've just preserved a copy of, and I've modified them by moving them in 0.1 millimeters, so minus 0.1, which is going to give us a 0.2 millimeter clearance for the final 3D printed parts, which is enough for a bit of wiggle room and will make sure they assemble easily. So that's why I needed to do these. You can see there's that slight difference now. That's why I needed to do these 0 thickness surfaces. So moving on, we need to do our peg, and the peg is another simple extrude, although it does have a few parameters that are worth mentioning. So here you go, using the same sketch here for the bore, edit feature. However, it is a 2-directional extrude, and one direction is an extent to the bottom of the bore, but I do have a offset of 1 millimeter, which means it's going to be giving me just that little bit of clearance if there's support material still in there, or if there's a little bit of a rough surface. And I do it this way instead of entering just a single number, because if my object changes shape or size, then it'll update automatically if I want to change that down the line. And I do have a slight taper angle of 1 degree, or minus 1 degree, which means that when that peg goes in, there's a little bit of clearance initially, then it's going to tighten up to a press fit. I don't want clearance as such here. I want it to be a nice press fit at the top of the hole, which is why I haven't offset that circle. And the other direction of our extrude is an arbitrary number. It's 10 degrees, 10 millimeters. And that's just enough to get me to the center point because I'm going to do a mirror. If I did change the size, I might want to change this manually again, but really, this is one you can just play around with. And I have to make sure it's a new body. It is not going to join to our side. New body. Okay, so we've got our peg, and we've got our side of the Reuleaux tetrahedron. And now the mirroring, which is what I mentioned. So the mirroring is really important because we need to use those new surfaces we created. So edit feature, and I'm going to mirror my bodies, and the mirror plane needs to be one of those zero thickness surfaces, not the offset, because then it would be in the wrong location. And you can just mirror repeatedly till you get the shape we need. So object pattern type bodies, 2 of the objects, and mirror plane is selecting here, which is one of our zero thickness surfaces. Okay, and if I zoom in, you can see here that nice amount of clearance, which is 0.1 by 0.1, so 0.2, which is what we want. And then we're going to do it again. So you just do another mirror with the other face, and then finally one more mirror with the bottom face, like this. And you're left with this shape. So let me just hide those outside components, because really they're all the same. We're going to export one of them and just copy them in our slicer, but we did need to do that because we needed to create this bad boy without any sort of complicated entering of dimensions and that sort of thing. This is our peg, our center peg, which holds everything in place. And they're currently separate bodies, so you just need to do a combine. So show you there again with combine, select one of them and select all the others, and select join. And then just for a little bit of extra strength and aesthetics, I added a chamfer in to all the edges. So this chamfer, and just a quick tip guys, if you want to select all the edges of an object, you just hold down shift or control and shift if you need to do it again, and just go over the whole shape like that. So just to show you again, get rid of this, hold down shift, and then just go over it till everything's selected. And that's going to give us a little bit of extra leeway to push the pegs into place, and then a little bit of extra strength here in the center. Okay, and we are done. So we have the separate objects here, ready to go to be sent to the printer. And of course, the peg is really important. I would print that with support material. But yeah, there you have it, guys. That's how much extra effort goes into making something designed for 3D printing. This wasn't meant to be a beginner's tutorial as such. It's meant to give you an insight into my design process, and to be quite frank, why I charge for a lot of my files. Because this takes me a lot of time, and I've spent a long time learning how to 3D model for 3D printing and design these objects. But in this case, this file will be free. It's here up in Gumroad. You can print your own Reuleaux Tetrahedron using my design. You can choose to donate some money to the channel, which I would really appreciate, but it's completely optional. And if you did enjoy this video on Maker's Muse, guys, please consider subscribing, because it is my aim to empower your creativity through technology. I look forward to seeing you again very shortly. Catch you later, guys. Bye.